Welcome back to our video. I'm splitting this one up into two videos. So this one's going to be still talking about perpendicular bisectors and the circumcenter, just with some more examples. If you've been keeping up, we went over a couple examples already. We're going to do these last couple here, and then we'll go on to our next topic. Number 4, in triangle MNP, point T is the circumcenter. Find the length of RT. So I want to know this length right there. It says point T is the circumcenter. So here's what I do know. The circumcenter is always going to be equidistant from the vertices of that triangle. So look at point M, point N, or point M and N and P. Those points are all the same distance away from the circumcenter. Those are all the same. Now, fortunately for us, we have an expression for two of those. So I can say TP and TN are equal to each other. Well, I have an expression for TN. TN is 4x minus 17. TP is x plus 10. We're going to solve that for x first. It doesn't say to solve for x, but we have to use that x value to get the other information in this problem. So I'm going to solve by subtracting x from both sides. That's going to give me 3x minus 17 is equal to 10. Next thing I'll do is I'll add 17 to both sides. 10 plus 17 is 27, giving me 3x equals 27. Now I'm going to divide by 3 on both sides to get x by itself, and I'll have the length of x. 27 divided by 3, 9. Now, I want to know RT. RT is this length right here, like I said over here. And the only way I can get that is if I know this side of the triangle. I know I have 14 here, and once again, these are going to form a right angle because it's a perpendicular bisector. So I'm going to pull out that right triangle here. I have 14. I don't know RT, so I'll call that x. And I have an expression for TN, 4x minus 17. So I can actually plug in 9 in for that x. And that's going to be 4 times 9 minus 17. What do you get when you plug that in? Well, 4 times 9 is 36. 36 minus 17. That's going to be 19, I believe. We always double check that in our old calculator there. So 4 times 9 minus 17. TN is 19. We'll take that 19. We'll plug it into the side of the triangle. And now, once again, we can use a squared plus b squared equals c squared. Your hypotenuse is the 19. So we'll set that up. X squared plus 14 squared equals 19 squared. Solving that for x will give you the length for RT. 14 squared and 19 squared. 19 squared is 361. 14 squared is 196. So I have x squared plus 196 equals 361. I'm going to want to subtract 361 minus 196. I'll get 165. And then finally, to get x, I'm going to take the square root of that number. X is going to be the square root of 165. So that's going to give me approximately 12.845. So the length of RT is about 12.845. We'll say 12.85. And I really have kind of maximized my space here, so I'll put this down here. And then I'll finally go over here and I'll write RT equals 12.85. All right, one more problem for circumcenters. Let's take a look at a coordinate plane. Triangle RST has the following coordinates on the coordinate plane. -2, 0. Call that R. S is 0, 4. And T is 8, 0. when you draw that triangle out, you're going to realize that this triangle actually is a right triangle. Can you tell where the right angle is? If you don't trust that that's the right angle, what you can do is you can look at the slope. That slope is going to be 2. And this slope is going to be -1/2. And if you remember, slopes that have opposite reciprocals are going to be perpendicular to each other. So you can test that visually using rise over run. And notice that these are going to be opposite reciprocals, therefore they're perpendicular. Therefore, we have a right triangle. Now the question says, plot the triangle, locate the coordinates of the circumcenter. You don't have to draw all the perpendicular bisectors, although you can. The perpendicular bisector here is just going to be halfway across the hypotenuse. This is your hypotenuse. And if you look back on our properties, the perpendicular bisector is actually right in the center of that hypotenuse. So we're trying to find the midpoint of that coordinate there. Let's write these coordinates out one more time. We have -2, 0 and +8, 0. And to get that midpoint, we're going to add these two up together. And divide by 2, we're going to add the y's together. And that's going to be 6 divided by 2, comma, 0 divided by 2, which actually ends up being 3, 0. If I plot the point 3, 0, that point is halfway, 2, 3, 4, 5, 1, 2, 3, 4, 5, halfway across the hypotenuse. It also ends up being the same distance from there to S. Notice that that length is the same as that length, is the same as that length. It's equidistant to all 3 vertices. Therefore, the coordinates of the circumcenter are going to be 3, 0. The circumcenter is always the midpoint of the hypotenuse in any right triangle. So if you find a right triangle, get the midpoint of the hypotenuse, you got your answer. Thanks for watching.